Okay, so let's take a look at a couple of the 2019 FRQs. Their format is similar to what you're going to have on the test. So for the first one, the first FRQ, you're going to write part of a class. You're going to write some methods for a class. And it's going to involve some logic, but there's going to be there are going to be methods that are given to you that you have to call. Remember, if it says implementation not shown, it means that you're going to call that method somewhere, either in part A or part B or both. And sometimes you have to call either what you've written in part A or call that method in part B. So this is the first question on the 2019 test. It says the AP calendar contains methods used to calculate information about a calendar. You'll write two methods of the class. And here's the name of the class, Public Class AP Calendar. And let's look at the methods that say implementation not shown. That's this first one. It's public static boolean, so it's going to return true or false, is leap year, and it takes in an integer representing a year. And this does say returns true if the year is a leap year, returns false otherwise. We don't have to write that. What we're going to be able to get out of this is we're going to be able to pass in a year. And I don't remember what years are leap years. Do you remember if 2002 was a leap year? I don't. But this would return a true or a false. All right. Then this is to be implemented in part A. And so that's something you're going to write, or if this were your test. Returns the number of leap years between year 1 and year 2 inclusive, meaning both year 1 and year 2 are considered in this. And it does show you saying that 0 is greater than or equal to year 1, which is less than, 0 is less than or equal to year 1, which is less than or equal to year 2, meaning those years are in chronological order. So I don't think you need to read further to write part A, but let's keep going. The next method, and remember, I don't like the way this is divided. I wish they would put lines in here to show you when one description begins and the other one ends. And I guess you can't do that if you're doing it on the computer, but I can since I'm doing it on paper. So let's look at the other things, the other methods. Here's another implementation not shown, so a method that we're going to have to call. And it says public static int. It's going to return an integer, first day of year, int year. And it says returns the value representing the day of the week for the first day of the year, and year is the year that's passed in, where 0 denotes Sunday, 1 denotes Monday, and 6 denotes Saturday. So again, implementation not shown. We're going to have to use that. There's another implementation not shown, and it's public static int day of year. It says returns n, where month, day, and year specify the nth day of the year. Returns 1 for January 1 because it's day 1 of month 1 in any year. And so if it was January 2nd, it would return 2. If it was January 3rd, it would return 3. If it was February 1st, it would return 32 because it's the 32nd day of the year, so on and so forth. And it passes in a month, a day, and a year. And I see precondition, the date represented by month, day, and year is valid. Okay, so they're not going to throw a loop and say you have to test and see if it's a valid month, day, or year. So we assume it is. And then to be implemented in part B, public static int. We're going to have a return statement when we write this because it's public static int, day of week. And let's see what it says. It takes in a month, a day of the year, and a year. It says returns the value representing the day of the week for the given month, day, year, where 0 denotes Sunday, 1 denotes Monday, and 6 denotes Saturday. So I do think that for part A, where you're just counting the number of leap years between 2 years, we can write it with just this part right here. For part B, I think we're going to have to use the other methods that are not implemented. So let's do a little bit of thinking. Let's go back and look at part A. It says implementation not shown. If you pass in the value representing a year, it will this method will tell you true or false, it is a leap year or it's not a leap year. What you're going to write, or what we would be writing, would be public static int. So we have to have a return statement, and it has to return an int number of leap years between 2 years. So this one should be pretty straightforward. So you're going to have to think through it. Say I'm going to have to start at a specific year, end at a specific year, count how many leap years are in there. So I'm going to have a counter. Every time I run into a leap year, that counter is going to have to go up by 1, and I'm going to return that value of that counter. So this seems pretty straightforward. So, no. Okay, so here's where we're going to write it. Here's the description. So I would say, let's put an open brace there, and let's create a counter. And if we are going to count the number of leap years, we have to set it to 0. Because what if the 2 years that they pass in are 2000 and I don't know when there was a leap year, but let's say 2016 and 2018, and there were no leap years in there. You have to be able to return 0. You also have to have something to add to as you encounter leap years. So this seems to me like this would be a really simple for loop. For int I equals year 1. So starting at year 1, I less than or equal to, and we would have to write it like this, wouldn't we? You would not get counted off for writing that. Year 2, and I do have to use the equal here because I want it to count up to year 2, year plus plus. And it seems to me that every time the value of I, which holds the value of a year between year 1 and year 2, every time the value of I is a leap year, I'm going to increment the count. So it seems to me like it would be, we would have to just call if and is leap year. There's the helper method. So if is, and we do have to pass in a year, but remember our loop counter represents a year. If is leap year, and I'm going to pass in the value of I, and capitalize that Y. Again, you would not lose point for that, I don't think. If is leap year, I, so I'm saying if I is a leap year, I want my count to go up. Count plus plus. And I don't need braces here, but if I put braces, that's okay. I do have to have a closed brace for my open for loop. And can you see what I'm missing? I think that will count every single leap year between year 1 and year 2, but this right here tells me I have to return something, and what do I want to return? I want to return the value of count, so return count. Whoops. Return count. And that should do it. Now I do have the scoring guidelines here, so let's see the score. It initializes a numeric variable. I did that. The numeric variable would be for counting the number of leap years. So I got that point. You would have gotten that point. Loops through each necessary year in the range. So they're looking for you starting at year 1 and going all the way to year 2. So if you don't go through all of those years, if you're missing this equal sign, you won't get that point. And you will not, it says you won't earn points if you consider years outside the range. All right, you get a point calls is leap year, and we did. With our loop counter variable, we tested to see if the current value of the loop counter was a leap year. Updates the count based on the result of calling is leap year. We did that right here. Count plus plus, and returns count, the count of the leap years. And let's see, responses earn the point even if they Do not use a loop. Do not use a loop and do not initialize the counter. Loop from year 1 to year 2 incorrectly. Do not initialize the counter. How would you lose points? You do not use a loop. You do not update or initialize the counter. You do not you return early while you're inside the loop. So, and you lose a point if you call is leap year as though it's not going to return a Boolean. Let's take a look at that. So here, I'd say if is leap year, and you could definitely do this as well if it is equal to true. But remember, that would be a comparative equal, so you would have to use the equal equal. You don't use the dot equals because Booleans are primitive variables, but you could just test it like this. If is leap year, it would return true or false, and if it is, it would count up. If not, it would not. Let's look at the canonical solution. The canonical solution is very similar to what I wrote. This one was pretty straightforward. We'll look at part B in a separate video.